Hey there, ninth graders. If you're looking at your new Ganita Manjari textbook and feeling a little overwhelmed by coordinate geometry, take a deep breath. You are in exactly the right place. Today, we're going to clear up all those doubts and walk through the complete step-by-step solution for exercise 1.1.
Let's just dive straight in. My goal today is to show you that coordinate geometry isn't just a bunch of random numbers on a page. It's actually this incredibly visual, super useful tool. By the time we finish, you're going to feel totally confident. We're tackling this whole exercise together, and trust me, you've got this.
Here's our game plan. We'll start by figuring out the layout of Rafine's room. Then, we'll knock out the 4 parts of the exercise one by one, finding the door's distance, grabbing the exact coordinates, checking for wheelchair accessibility, and finally, comparing the main room door to the bathroom door.
All right, part 1, Rian's room. Let's get our spatial bearings first, because honestly, everything in this exercise revolves around this one specific floor plan.
Now, what's really cool about this setup is how it turns a standard bedroom into a literal mathematical grid. Picture this. Down in that bottom left corner is our origin, point O, sitting right at 0, 0. Stretching out to the right from there is the horizontal line, our x-axis. And that vertical line shooting straight up, that's our y-axis, which actually doubles as the left wall of the room. Keep this layout locked in your mind because it's the foundation for literally all our answers today. Okay, moving on to part 1, the door's distance. Now that we've got the map straight in our heads, let's tackle the very first question of exercise 1.1.
So here's what we need to solve. We're looking at the main door, marked from D1 to R1. The question is asking for its distance from 2 specific places, the left wall and the horizontal x-axis.
Well, the key is finding exactly where that door begins. If you trace over to point D1, you'll see it starts at the number 8 on the x-axis. Since the left wall is at 0, the distance from that left wall is just 8 units. Simple, right? Now what about its distance from the x-axis? Think about it. The door is built directly on that x-axis line. It hasn't moved up or down at all. So its distance from the x-axis is exactly 0 units.
Boom! Part 1 is done. Let's slide right into part 2, which honestly just builds directly on what we just figured out.
This question is just asking for the specific mathematical address, the coordinates, of that starting point of the door, D1.
Let's bring that visual back. I want you to drag your eyes along the bottom, right across that horizontal line. Find D1.
Finding this perfectly illustrates one of the golden rules of coordinate geometry. First, we already saw D1 sits at the number 8 on the x-axis, so our x value is 8. Now here's that golden rule. Any point sitting totally flat on the x-axis will always have a y value of 0. It hasn't climbed up that vertical ladder at all, so we put it together in our standard x, y format, and we get our exact answer, 8, 0.
All right, part 3, wheelchair and width. This is where things get genuinely interesting, because we're taking these abstract numbers and applying them to a real-world scenario.
This is a fantastic multi-part question. They give us the coordinates for the other side of the door, R1. We need to calculate the physical width of the door and then figure out if it's wide enough for a wheelchair to easily pass through. This is what math looks like in real life.
So, let's crunch the numbers. To find the width, we just look at the space between where the door starts and ends. It ends at 11.5 and starts at 8. Subtract 8 from 11.5, and you get a width of 3.5 units. To make this tangible, let's say 1 unit on our grid equals 1 foot. That means our door is 3.5 feet wide. But wheelchairs are usually measured in inches, so let's convert it. There are 12 inches in a foot, right? Multiply 3.5 by 12, and we get exactly 42 inches.
The crucial step here is comparing those numbers. We just found out our door is 42 inches wide. Now, a standard medical wheelchair is usually about 32 to 33 inches wide. That means a person in a wheelchair only needs 32 inches of clearance, and we have 42. That leaves almost 10 inches of extra wiggle room. So our conclusion? Absolutely yes. This door provides super comfortable and easy access for anyone using a wheelchair. Awesome. Let's push forward to part 4, bathroom versus room, and see how all this sets us up for our final challenge.
We fully analyzed the main room's door. Now, the problem asks us to look at a second door, the bathroom door, using coordinates B1 and B2, and figure out if it's narrower or wider than the main door we just measured. Let's get visually oriented one last time. Notice how you have to shift your focus here. We aren't looking at the horizontal x-axis at the bottom anymore. Instead, look up the left wall, the vertical y-axis. Right there, you'll see B1 starts at 1.5 and B2 ends at 4.
The math here is exactly the same as before, just on a different axis. First, we spot our y values, 4 and 1.5. Second, to find the physical distance between them, we just subtract the smaller number from the larger one, 4 minus 1.5. And that gives us our third step. The bathroom door's width is exactly 2.5 units.
And this beautifully highlights our final answer. On one hand, we have the bathroom door, which we just calculated at 2.5 units wide. On the other, we have the main room door, which we already figured out is 3.5 units wide. Comparing these two, it's pretty undeniable that 2.5 is less than 3.5. So the bathroom door is definitely narrower than the main room door.
And just like that, we have logically and successfully completely solved exercise 1.1. You've seen firsthand that coordinates aren't just textbook ideas. They map out rooms, they measure physical spaces, and they even help us figure out real-world accessibility. You should be feeling incredibly confident moving forward in your math journey. But before you go, I want to leave you with something to think about. If you had to map out your own bedroom right now using a coordinate grid, which corner of your room would you choose as the 0, origin point to make navigating in the dark mathematically simple? Think about it, keep exploring, and keep calculating.